This playlist deals with some aspects for Eurocode 2 version 2023. Watch this channel or playlist for further selected topics. The video is about clause 11, detailing of reinforcement, part 6, and it will deal with anchorage. And in more detail, it will give you two examples of calculating the anchorage capacity of a headed bar. This is an example of an anchorage of headed bars in tension. We'll take a concrete element with two headed bars anchorage with a distance of 160 millimeters center to center, and AX equals 150 millimeters and AY equals 40 millimeters. A headed bar looks like this. We've taken now the headed bar with a circular cross section. The anchorage length is LBD. The diameter of the head is 40 millimeters. Thickness of the head is 10 millimeters. And the bar to be anchored is 10 millimeters. You can see here in red how it can look in practice. In our example, in the ULS persistence, the force to be transferred is 30 kilonewton. So now we will calculate this headed bar of diameter 10. So the concrete quality is 30 megapascal. The maximum granular size, the max is 16 millimeters. It's uncracked because we make the assumption, or it's not the assumption, that it is at the vicinity of the support with less tensile stresses in it. Diameter of the rebar is 10. Then we have seen AX and SX and TH already, and the other two values. Now we will calculate if this headed bar is okay. First of all, we take the capacity of the head without additional anchorage length. And we look at the different conditions. The conditions that the concrete quality must be bigger than 25 is okay. The diameter must be smaller than 25. This is also okay. AY is 40 millimeters and must be bigger than 3 times the diameter uncracked, but the diameter is 10, so this is okay. AX is 150 millimeters, but must be bigger than 2AI plus 1.2 VH, which is 116, so 150 bigger than 116, this condition is okay. SX must be bigger than 4 times AY. AY is 40, so 160 equals 160. This is okay. DDG is 16 plus D lower, and which here in our case is 32. D max, we have taken D max equal to D lower. So it's 32 millimeters, 16 plus 16. And VH must be between 3 times V, must be between 30 and 4 times TH 40. So VH is 30, so it complies too with this condition. And then we can, because all those conditions are fulfilled, we can just assume that the tensile stress in the anchored headed bar is 435 megapascal in ULS persistence. So the total force that you can take is 435 times the cross section is 34 kilonewton. So it's bigger than 30. So this headed bar is okay. And we don't need any anchorage length. It's only the head of the bar that can take the full anchorage for its own, on its own. Now we have a look at a detailed calculation. You remember, this was the different steps that we have to follow for a detailed calculation. Doing so, we have first to calculate CD, the nominal concrete cover, which is the minimum of half spacing, AX and AY, or 3.75 times the diameter, which is 37.5 millimeters. This is the 3.75 is in the formula 11.3 to calculate LBD. So this is LBD is the anchorage length of a straight bar. So that's why this 3.75 is appearing here. So we have 37.5 millimeters. Sigma SD, the first step, is of course the total force that we want to transfer divided by the cross section gives you 382 megapascal. The anchorage length, straight anchorage length for this tension, tensile stress, when we use the formula 11.3, and then you fill in the different KLB and KCP and so on. We've seen the previous videos. Sigma SD is 382. Again, pay attention to phi over 2 because this ratio must be bigger than 0.6. So that's why I put it in red to make it clear for you that you should not fill in here the phi, which is 10 over 20, which is 0.5. No, it should be at least 0.6. Then we see that the needed anchorage length is for sigma SD is 200 millimeters, must be bigger than 100. So okay. Now we calculate sigma accent SD, which is at the head of the headed bar. We've seen this formula. To use this formula, you need AD, which is this, because we have rebars anchored in a row. So we use this formula. Then it's just fill in all the different elements. It's not that complicated, but you see then that AD at the end is 40 millimeters because this is 0 and this is 1, so it's 40 millimeters. Nu is equal for an uncracked section 11, and DDG we have seen is 32 millimeters. KHA is equal to this formula and it's 8, which is 3 squared minus 1, which is 8. FCD is 20. And then we go to step 3. We calculate with sigma accent SD. We calculate the total anchorage length. Sigma accent SD is 751 megapascal. Must be smaller than 1760, which looks in the beginning as quite ridiculous, but this has to do with an absolute maximum capacity. LBD, then the anchorage length needed for sigma accent SD is then this value, which is 552 millimeters. Now, you see sigma accent SD can never develop in a bar of 10 millimeters. That's not possible. And not in, so because the maximum yield stress that is allowed is 700 megapascal without any material coefficient on it. So this cannot be. We can now state that, for instance, if you take a maximum value of 435 instead of 751, then you will see that the needed anchorage length is 243 millimeters. So this anchorage length is irrelevant because of this very high tensile strength. Then we go to step 4, which is the difference between those two anchorage lengths times 1.1, and immediately we see that the difference or that LBD is negative. So this only means that we do not need an anchorage length as such. The head completely covers the whole system. Now we can take a second example with, it's a little bit similar to the previous one, but now we will have a diameter of 25 and a head of 75 millimeters. And we need a transfer of 200 kilonewton. Again, these are different factors. And this time we calculate with a cracked concrete. First, we check the capacity of the head without additional anchorage length. Then we will see if you go through the different conditions, like we've done in the previous slides, you will see that we fulfill all conditions. That means that we can assume 435 megapascal of tensile stress. And that means that the total force that can be transferred is 214 kilonewton, which is bigger than 200, so it's okay. Now we go to detailed calculation. We calculate CD because of different values of AX and AY and CS. We arrive at 94 millimeters for CD. Calculate sigma SD, which is now 407 megapascal. Calculate the anchorage length needed as for a straight bar with 407 megapascal as sigma SD. And we have 771 millimeters. Then we calculate sigma accent SD, that's the resistance of the head, or the tensile stress at the head. We've seen that this formula, we fill it in, we have 100 millimeters, and it's cracked, so nu parts partial is 8, DDG stays at 32 millimeters, the factor KHA is 8, and FCD is 25 divided by 1.5, it's 16.7 megapascal. So sigma accent SD is then 422, but now if you look at this is smaller than the 435. So in the first method, when you fulfill all the conditions, you could use 435 as a tensile stress. But if you make the detailed calculation, the maximum tensile stress is only 422, not 435. Now we calculate the needed anchorage length for sigma SD and sigma accent SD. We subtract it, multiply by 1.1, and still we find a negative value. So even if this value is smaller than 435, for the total force FD, it is almost equal. So it means that the additional that no additional anchorage length is needed, and that the head takes it all.